Hello dear students, let us start our discussion about motion in a plane. Motion in a plane. As we know that when any object moving in any plane, then suppose that this is a xy plane and any object is moving in this plane from one point to another point by taking this track. Okay, suppose that if the object is placed at an instant of time t at point P, and after some time, suppose that after time t dash, at any time t dash, object reached at any other point P dash. So what will be the displacement created by that object? So to calculate the displacement created by that object, first we have to join the point P from the origin. This provides the position vector of the point P with respect to this origin, and if we join O to P dash, then this line provides the position vector of the point P dash with respect to O. So when object is moving from P to P dash, then the object must create some displacement during motion or going from P to P dash, and this displacement will be equal to what? Suppose that the displacement position vector of point P with respect to O is R1 and this one is R2, then this can be represented by displacement delta R, that can be expressed as in terms of R2 and R1, that is R2 minus R1. So how much time taken to reach the particle from P to P dash? This will be equal to T dash minus T, that is delta T. So in time delta T, if the particle makes a displacement of delta R, so what will be the velocity acting on the object? So we can define velocity of any object that can be expressed as rate of change of displacement by time. The rate of change of displacement of any object is known as velocity. So if you want to calculate this velocity in two different components with the help of the resolution of a vector, suppose that velocity of the particle along x-axis and velocity of the particle along y-axis. So you have to first find out what is the position coordinate of the point P. So if we assume that the position coordinate of point P is x1, y1 and the position coordinate of point P dash is x2, y2, then how much distance traveled by the object along x-axis? So this will be delta x, that is x2 minus x1, because if you draw perpendicular from P and also P dash, then if they are meeting at x-axis at different 2 points A and B, then OA is treated as x1 and OB is treated as x2. And if we draw perpendicular on y-axis from P and P dash, then suppose that this point is C and D, then OC is treated as y1 and the value of point D, from the distance of point D from O, will be equal to y2. So in time interval delta t, the particle must goes along x-axis. How much distance? This is x2 minus x1. This is treated as delta x, and in time interval delta t, particle also goes along y-axis by a displacement of along y-axis, that is delta y, that will be equal to y2 minus y1. So you can write it as delta x equal to x2 minus x1 and delta y is equal to y2 minus y1. So if you want to write what will be the displacement created by the vector delta r, this delta r can be expressed in two different terms. Suppose that this is the delta r vector. If we want to resolve this vector into different component along x and y axis, then we have to draw, this is y axis and this one is the x axis. If we draw perpendicular from here and also on a y-axis, then we get that the value on y-axis and x-axis on the x-axis what is, this is delta x, and on y-axis this is delta y. So if in the direction of x-axis, if the particle is going by a displacement of delta x, and on y-axis if the particle is going by a displacement of delta y, so this vector delta r further can be expressed as what, delta x dot I cap plus delta y dot j cap. So if we write the value of here, then the velocity of the particle can be further expressed as delta x by delta t I cap plus delta y by delta t plus dot j cap. This is the instantaneous speed of any object, or the speed during which a particle goes from point P to P dash. But assume that if the position of point P dash from P is very large, then there will be very large distance traveled by the particle, and the time taken is also large. So if we want to calculate the instantaneous speed of the particle, instantaneous velocity, suppose that instantaneous velocity of the particle, then we have to divide, we have to take this time interval as very small. So if we take a limit as delta t tends to 0, then we find out the point P dash and P are very close to each other, and the displacement created by the particle is in very small interval of time. That is, such type of displacement divided by time provides the velocity, instantaneous velocity. So instantaneous velocity can be expressed as limit of delta t tends to 0 of this value, that is delta x by delta t I cap, and also plus delta y by delta t j cap. This further can be written as limit delta t tends to 0 delta x by delta t I cap plus limit delta t tends to 0 delta y by delta t j cap. So now this value can be treated as dx by dt. So this v further can be expressed as dx by dt I cap plus dy by dt j cap. This provides the instantaneous speed of any object at any point or near about any point. So if any object moving just in between from P and P dash with any velocity, then that velocity have a value of dx by dt I plus dy by dt j. Okay, this is the simple formula for the velocity, instantaneous velocity. If we want to calculate what will be the acceleration acting on the particle, then it can also be easily calculated with the help of this method. So what will be the similarly, if you want to calculate what will be the average velocity, it means delta x, that value, it means v average that can be equal to delta x by delta t I cap plus delta y by delta t j cap. This is the average velocity. But instantaneous, what is the instantaneous velocity? That is equal to dx by dt I cap plus dy by dt cap j cap. Okay, so if we apply this, then we also find what will be the value of instantaneous acceleration and average acceleration. So if you want to find out what is the instantaneous acceleration, so instantaneous acceleration can be defined as d by dt of dx by dt I plus dy by dt j, because we know that the rate of change of velocity, this is velocity, instantaneous velocity, the rate of change of instantaneous velocity is known as instantaneous acceleration. So this will be equal to d2x by if you put this as, then we can write it as vx I cap plus vy j cap. It means the velocity along x-axis and this is the velocity along y-axis, instantaneous velocity along y-axis. So if you put at here what dy dt of vxi cap plus vyj cap, then we find that dvx by dt is I cap plus dvy by dx j cap. So this is the acceleration acting along the x-axis ax plus this is ay acceleration acting along the y-axis. So the instantaneous acceleration can be expressed in this term. Okay. So what will be the average acceleration? So average acceleration must be calculated with the help of the initial acceleration and final acceleration. If object is moving under non-uniform acceleration, or if the acceleration acting on any object is continuously increases by a fixed value, then the average acceleration acting on the object will be treated as the sum of the initial and final acceleration divided by the time in which acceleration changed. But if acceleration acting on any object is constant, it means object is moving with a uniform acceleration motion, then the acceleration acting on the object is always constant, and acceleration acting on any object is further divided in two different directions, as along x-axis and also along y-axis. So the acceleration acting along x-axis is defined by a symbol that is ax, and the acceleration acting on the object defined by another symbol that is ay. This provides the acceleration acting on the object along y-axis, and this provides the acceleration acting on the object along x-axis. Okay, so this is all about the motion in a plane and different speeds and velocities. Also the acceleration acting on any object. You can solve different types of numerical problem based on these formulas. They are very simple and easier, so you solve it. Thank you.